Hello bachcho, so let's see this question. So the question says an ideal gas has a molar heat capacity Cv at constant volume. Okay, find the molar heat capacity of this gas as a function of volume if the gas undergoes the process T is equals to T naught e to the power alpha V. Okay, so here in this question what we need to do is first of all we need to find the key concept that will be used in this question. So the key concept that will be used in this question is what? So that key concept will be what? First law of thermodynamics. So again, we will use the first law of thermodynamics. Okay. So here in this question, we will use the first law of thermodynamics. And what first law of thermodynamics says? dq is equals to what? du plus dw, where dq is the heat and du is internal energy and dw is what? Work done. So now we have to solve this equation, and we can also write that dq is what? dq is what? c dt. Okay, molar heat capacity, and we can also write that du is what? So we can write the value of du is cv into dt, where cv is the molar heat capacity at constant volume. Okay, and dw will be equals to what? dw is pdv. Now just differentiate the given equation. Then what we can write is the given equation is t, which is t naught e to the power alpha v. Now we can differentiate this equation. So this will be equals to dt T naught e to the power alpha v into what is the differentiation of alpha into v. So alpha will be common and the differentiation of v will be equals to dv. Okay. So now I can write the values here. So we can write that dt divided by dv will be what? T naught into e to the power alpha v. So it is actually equals to capital T into alpha. Okay. So we can use this equation here. So how can we use this equation here? So we are using the FLT, first law thermodynamics. So dq is equals to du plus dw, and just put the values here. So c into dt is equals to cv into dt plus p into dv. Okay. So what is the we can just divide the dt with the whole equation, then we can get this. We can get the value c is equals to what? cv plus p dv by dt. Are you getting my point, everyone? We can write it. We can write it like this. Okay. Now this is C, which is equals to Cv plus P dV by dt. So what is dV by dt? It is 1 upon alpha t. So we can write this is P by t into alpha. And now we are again using one more equation, which is what? Equation of the ideal gas. So this is PV is equals to nRT. Here n is 1. So we can write PV is equals to R into T. And we can write the value of P by T will be equals to what? R by V. Now we can put this value P by T here, and what I will get is C will be equals to CV plus P by T will be equals to what? R by V. So we can write R by alpha into V. This is my final answer. So the final answer of the molar heat capacity is what? CV plus R by alpha V. I hope you understood it well. Best of luck.